querés al final, si quieres mencionar también el stream, así la gente que nos está viendo, ya se van sumando. La gente que nos ve en el stream también puede participar por el stream. Así que bueno, gracias de nuevo a todos, que hayan disfrutado la comida. Ahora, todo. Así que bueno.
Pero entonces, ¿cómo comparto la pantalla?
Yo te voy a subir, compartir, presentar. Si querés presentar la pantalla, ahí eso
Porque
puedes
soy
minimizar.
backstage. Ahora
Sí,
soy.
sí, sí. Ahí si querés minimizar y compartir lo que vos quieras. Igual mientras se va conectando más gente, seguro. Viene más gente. Bueno.
Comparto el link, ¿no?
Sí,
por arriba.
Estamos frenando por todos los canales.
Mira, yo no sé si funciona. ¿Ahora qué?
Ahí está. Un suelto. Cuando me digas yo lo veo en escenario, pero primero te lo daría a vos.
Y es solamente esto, ¿vale?
Sí, sí.
Do you want to look at me or because I need to press this, and I think it's on the
Los primeros 2 minutos preséntense porque no voy a estar yo.
Okay.
Nosotros quedando online, estaba yo presentándolo. Preséntense y bueno, digamos, salgo la música. Y por favor, a los que están en la sala, hagan silencio, porque se escucha todo.
Acá unos bonobones.
Gracias.
Vayan pasando así.
Gracias.
Hello, we are very happy to be here. This is the formal team, and we're going to do a workshop today for East Argentina Hacker House. We walk you through a few products from Momo, and then we'll discuss a bit about the hackathon. You are unfolding.
I'm Evgeny, and we're part of the DevRel team at the Womo Foundation.
All right, let's get started. Yes. So the title of this workshop is called Beyond Bridges: Advanced Approach of Building a Multi-Chain App. And the reason for that is that we also want to remove the common idea that interoperability is only about bridges. It is a bridge, but we have so many products today in the interop landscape. They are super interesting, and we're really happy to share that. So these are some of the workshop goals. We will quickly go through the state of interoperability. Why you might want to build multi-chain, and then what is WOML as an interop protocol. And finally, we will go through a few of our products, and all of them you can integrate them in your app for the hackathon if you want. Yeah, so let's get started. So what's the state of interoperability today? Well, that's one of the reasons liquidity fragmentation is an issue today. So it's about 40 versions of USDC currently. And especially if we are today in Argentina, but especially if you live in a country where stablecoin is commonly used, you can see that it's a problem, right? So we have so many chains, and there's a constant need for bridging, right? It's you don't have anything in one ecosystem only, and this is why you need interoperability. So just quickly, this is in with some numbers. It's this today. I took that screenshot today actually from WamoScan. So just as an idea, you can see there is about 70 billion in total volume that has been facilitated by wormhole since the beginning of the protocol. So what we think of interoperability being maybe something that was a nice to have a few years ago is not something that is nice to have today. Like you must have a solution for making sure your token can go multi-chain in the easiest way possible. Total amount of message is like 1.1 billion. Like it's very an important part of the market, and especially now that institutions are coming and it's the biggest amount of like the volume is just increasing. We cannot just be in a silo. We cannot just have everything tokenized on one chain and hope for the best that maybe your user are going to come in to you on your chain. Like it's not really how it's working at the moment. And yeah, just for that, you can see most of the volume goes from Ethereum to Solana. Wormhole was the first bridge between Ethereum and Solana, and that's mostly why you see this dynamic there. So yeah, cross-chain messages is everywhere. So you can do from token transfer, so including swaps, but also any borrow lending protocol, any sorts of like yield optimization you can see on certain protocol on Ethereum, and then you also have it on Solana. Oracle, Pith Oracle is a really good use case for wormhole. Governance is another one, especially like currently with like the bigger player coming in. They have also governance token that comes into picture. So cross-chain is just everywhere you can think of today. That's just like a quote to show how important it is. But inefficiency in cross-border payments alone costs businesses and consumers about like 1.1 trillion annually. So that's basically what DeFi is offering as a massive value, is the fact that we can transfer tokens instantly, almost instantly, without like cross-border, and by having like very low fee when it goes from one ecosystem to another. So it's very important interrupt get to the points that is so seamless and so cheap and fast that you don't even know it exists. So one of the reason also we like one of the questions we often get is, why should I build multi-chain? Like, why should I issue or a stable coin that is able to go from one ecosystem to another? Why is it important that I can swap things on my app like from one chain to another? One of the reasons is that it's user growth, right? If you build an application in one ecosystem, the user you're getting, they are familiar of your ecosystem. Let's say I built something on Solana, basically you get all the Solana user, that's great. Now, what about you want to grow? Like the user growth has to come from people either outside your ecosystem, or your app is so good that they're gonna come to you. But if they come to you, they probably have liquidity from another chain, right? So you're gonna need to make something, or at least your application must be able to accommodate those users. So multi-chain gets you bigger, like increase your user growth. Scalability is the same. You attract more liquidity, more fund from other places, and not just the ecosystem you build in and you're native from. It, of course, that's a consequence, but it has a trivial growth. And then the new cases is, we've seen it many times where you get new people coming because your chain or your application allows to have different use cases. Like you have a better, I don't know, intent protocol. So they're coming to you, but they are not necessarily coming with liquidity and fund or assets, they come from your own chain, right? So that's another thing. Chain abstraction, of course, it has been the big word in a few years now, but it's so crucial now that wallets, interrupt solution, apps like just work. Every layer of the stack needs to be fully able and capable to work together, and to not have this barrier and this siloed architecture where you actually stack somewhere and then you need to bridge and then to wrap the assets and then you need to transfer and then you need to go back because you don't have the gas fee on that specific chain. Like it's just the chain abstraction has to be to a level that is very seamless for the user. And so all of these things is what Wormhole really want to work with. So what is Wormhole? Do you want to talk about the full stack?
Yes. Right. So this is an example of the wormhole stack. So there's multiple layers that you can use, so multiple products that are part of the stack. First, one of them is Wormhole Connect. Wormhole Connect, we're going to dive deeper into each product and how you can implement them later through this presentation, but it's kind of the first overview. Wormhole Connect is a React UI widget, so it's very easy to integrate inside your application with just 3 lines of code. Basically, you just use a library, and out of the box, you get basic cross-chain transferability for specific assets. If you want more adjustability, it's also possible, but in theory, you could, with 3 lines of code, have first USDC transfers between a number of chains. Then we have wormhole verification. That's kind of the underlying basis of all of it. So in theory, any message can go from one source chain to any destination chain with any arbitrary message attached to it. So you have full flexibility to send any messages that get verified by wormhole verification under the hood. And Relays is kind of the next step of it. So once you let's say you use Connect to send a message, wormhole verification is used under the hood to verify that the message is actually, let's say, a token is burned on one chain. Then a relayer picks up that message and sees, okay, cool, we have a message that was that token was burned on one chain. So now I can take that and relay the message to a destination chain and take kind of the next action based on the fact that the token is burned. So let's say then I will mint the token on the other chain for transfer. And one more scan is just an explorer, which makes it easy for you to see, hey, what did I do just now?
Yeah, so that's maybe repeating a bit what we just said earlier. You can go ahead.
Yeah, sure. So these are just some considerations for interoperability in general that we think are very important. One is any product that we want to build should be open source, fully open source, so anyone can go ahead and use it. It should be verifiable code. We want to focus on making it as secure as possible, and the user experience should be as good as possible. But obviously, these are things that collide in a way, right? The more security you have, sometimes user experience can get less in a sense. So it's very important to consider security, but at the same time the user experience while not compromising too much on the decentralization of the product. So let's dive deeper into the technical architecture.
No, it's just, okay. Sorry, I thought it was the next page. No,
Okay.
you can go.
These are just some technical terms. We have a VAA, which is the Verified Action Approval. This is just a technical term that you don't need to remember. It's just the way that we call actually a message that is verified by wormhole verification. A guardian is one of those verifiers that we have. So it's our guardians are the biggest validators in the space, and so they run full nodes on every supported chain that we support. So we don't need to rely on RPC providers to actually make sure that the message was actually created on a specific chain. And the relay we already talked about. Just
the guardian is 19 of them, and
yes.
the threshold is 13 to validate the message. So it's actually 13 nodes that you need to have a verified VAA that is signed for the message to go ahead. So it's really decentralized in that sense.
Yes, that's the whole cycle. Let's go quite quickly over it. So, like I described before, I don't want to go too technical here, but in just so you can see how it would flow from one contract on the source chain to the destination chain. So, very quickly on contracts, let's say we speak about an example from Ethereum to Arbitrum. I have a token on Arbitrum. I want to send it to Ethereum, and I want it to work with burn and mint. So whenever I send a transaction, the token gets actually burned on Arbitrum and then only minted on Ethereum, let's say. So how it works under the hood is that we have a source contract, that's the token contract in this example, which calls into the wormhole core contract. The wormhole core contract then emits a message. So it emits a message to the Guardian chain to the Guardian network that says, hey, we have here on Arbitrum a token burn. Then this message goes inside the Guardian network. So all these 90 Guardians take a look at this message and through their full node try to verify if that token burning actually happened. If they all independently agree on that, or not all of them, but 13 out of 19 agree on, okay, this token is actually being burned, only then the message, a VAA that we call it, a verified action approval, gets created, and only then the target contract can take the message from the Guardian network, query it, verify it against the wormhole core contract, because the wormhole core contract can then verify all the signatures from all independent Guardians, and only then a token could get minted on Ethereum after the token is burned on Arbitrum very quickly.
Yeah, and it always needs to wait for finality. That's another thing. So that's also why it depends the chain you're using. Sometimes it goes faster than others based on that. Okay, taking token multi-chain, natively multi-chain. So
What does okay. So the question is, what are actually native multi-chain tokens? We have one of our products that we call NTT, which is the Native Transfer Token Framework. And we consider a token to be native if the token is owned by the deployer itself. So it's not wrapped around a contract that controls the token, but it's actually fully owned and has been deployed by a deployer wallet themselves. So you have full token ownership over the token. In theory, you could just design it to be upgradable or not, but it's fully under the control of the developer. And customizable goes kind of in the same way. If you control the token, then you can customize the metadata bit as much as you want because you have full token ownership over that token contract. We have two different ways of.
Okay, yeah, we can. So on those entity, one thing is to remember for the native token transfer is, as he said, is that it's not a wrapped asset, right? So you will have a token, like a contract that is deployed. The entity contract is deployed natively on all chain that you need to send your token to. So we have two deployment model. One is a burn and mint deployment model, and the other one is a hub and spoke. So the first is burn and mint. So like the way it works is that your token will be burned on chain A, so on the source chain, and minted again on the destination chain. And that is usually what integrators choose when they have a new token. That's the most common deployment model for that use case. Now you have another one, which is for existing token, and it's called hub and spoke. So hub and spoke is a bit similar to like a lock and mint, let's say. So you will have a hub chain. Let's say my token has a hub chain on Ethereum, and I want them to exist on like many other chain, right? Then all those other chain become spokes chain. Okay. So my token is not burned and mint again, is locked on the hub chain and minted again on the spoke chain. Yes, so this is a bit what Evgeny mentioned before, but what are the advantages of using NTT against what we call WTT, which is the wrapped token transfer? So one will use the core bridge, like the core messaging, and you will end up with a wrapped asset. Otherwise, you can decide to go natively multi-chain, right? Which is this one. And one thing to remember, if you had to remember anything, it's really that entity gives you a lot of flexibility and it gives you ownership over your contract, okay? So That means the bridge is not in control of your deployment. You are in control of everything. And one of the feature that is very important, and I think that's also why integrator use it, is that you have sort of like all the access roles. So you can have rate limiting feature, you can have posing, you have all of this you can configure it yourself, right? So it's extremely flexible in the sense that it really caters the needs of your own token design. Like you don't have to change, if you design your token in a certain way, you do not have to adopt another token standard, like it will be the case for other protocols. We don't do this. Like the entity is a framework, right? So your token is designed the way you want it, you upgrade it the way you want it, and you add the security setting that you want. And on top of this, there is no lock-in to wormhole, which means that the flexible verification is you can add a verifier, like let's say you want a third-party verifier like Axela. Okay, sure, you want extra security, up you add a third-party verifier, or you can run a verifier yourself. Like that, or you don't care, you think wormhole is all good and you can just go with wormhole. So the idea in it is really that you get control, you keep everything you need, and what you don't want, you don't have to get it. And that, I think it's at the core idea, the way we design that product.
Just maybe to double down on that and look at the graphic really quickly before. So with NTT, you could in theory have in the middle step. So right now, all verification in the example that I described would go through the Guardian network. So the Guardian network, if 13 out of 90 Guardians verify independently that something happened, then the transaction would get to the destination chain. What Pauline just described is that you can add any kind of additional verification. If you say that this Guardian verification is not enough, I want to have another threshold, let's say Axelar or your own, then in addition to the Guardian network here in the middle, you would have here in the middle, you would have a different verification mechanism that would, independently of wormhole, also verify that something happened, and only if those two verification mechanisms independently say, hey, cool, we definitely made sure, independently from each other, that the token is burned, only then would a mint happen. So you can add as much additional security that could be centralized or even more decentralized as much as you want with NTT, which makes it this kind of very flexible framework.
Can we pass that?
Thank you.
Yeah, so how can you start? Well, the easiest way for the entity is really to use the CLI. So you will always need to deploy a token. Of course, that's independent of anything with wormhole. So you will have your token deployed on one chain, right? And your token, let's say you want to go from Ethereum to Solana. You will have your token deployed on Ethereum. Then you will choose a deployment model. You will also have it deployed on Solana, where both tokens need to exist. But then you will choose a deployment model. So either you would choose a burn and mint, if it's a new token, or you would choose, for instance, a hub and spoke. And that is up to you. Like you can go either way. Like it's based on whatever you need for your token. Then you will get the CLI, and basically you have comments on the CLI, and you will be able to execute most of the comments without like anything else than just the CLI. And then if you want, you can build your own front end, of course. But as we mentioned at the beginning, there's a widget that's called Connect. And that's just like basically a front end, it's a part of a React component, and it used the entire wormhole like under the hood. You won't need to do anything extra to just be able to use wormhole and connect it with the widget. So we don't need to go through that, but those are basically, you create your token, you create your entity contract, you configure it, and then you will execute those commands. So you will have the source chain, then you will have the chain that you need to add, and everything kind of get into like a very smooth process, right? It's not something that should, hopefully, get you hours to get started. But obviously, if you haven't deployed even your token from the beginning, you're going to have to do that. But that's outside the time that it takes for an entity to work. And as we say, all of this is permissionless, right? Like you don't need us. Like you can do all of this on your own, and yeah, just like plug it in into Connect, and it would just work like this. Yeah, those are some of the people they use Entity. Actually, the wrap state is one of the one from Lido that use the double verification with Axela. So this is a good example where you will have on, I think it's on BSC, but yeah, they use Axela and Wormhole to make sure that there's like extra layer of security. So yeah, you can go next to the next.
Okay, so now that we basically all the time were speaking about our native token transfer framework, which is based on the finality time of the chain. Why is it needed to be based on the finality time of the chain? Because we want to mitigate reorg risk. Before we are sure that the message is actually finalized, anything could happen. Blocks could get like a reorg could happen, so funds could get lost. And in order to prevent that, we make sure to wait the complete finality time, which on Ethereum is 20 minutes. I mean, if you want, there are certain actions that where you're fine to wait 20 minutes, but usually you want it to be faster. You can't really build on top of a multi-chain protocol, specifically if you want to do something like cross-chain borrow lending and wait for 20 minutes before one action on one chain is going to be final. So in order to mitigate that, we built a product called Wormhole Settlement, which is an intent-based cross-chain framework. And how it works is that in order to mitigate that reorg risk, we work with solvers that take on that reorg risk. So there's an additional fee, a small fee, which you need to pay a solver that takes on that risk of fronting you the asset before the asset is actually finalized on the source chain. So before that, the solver takes the risk that potentially that asset could not be final on the source chain and still fronts you the assets that you want to get on the destination chain. And for that, you kind of need to pay a small fee, but that speeds up the process drastically. So instead of waiting for 20 minutes for the regular NTT transfer from Ethereum, you will wait about 20 seconds, which just definitely unlocks a lot of cool new use cases while still keeping security for yourself.
Yeah, that's just like some of the. So the product, the Wormhole Settlement, is been originally built by a team that is Mayan Finance. So actually, you can go on, like if you use Wormhole, even the portal and so on, it takes the Mayan route, right? Like that is the route that it's always picked up, and it's actually the fastest we usually have. But yeah, if you want to use Wormhole Settlement, for instance. Most of the use cases you will get is like cross-chain swap. The one I found the most interesting is probably swap plus action. And that's like really where you, for instance, let's say you want to get into an app and you're supposed to deposit USDC on Ethereum, but you only have USDC on Solana. Well, then you can build a product basically where you would deposit, and then they will, basically the intent would take the swap, the mint, and then they would allocate your funds like on one click. Like when you think about it, how much step it would have taken if you will have to do it all of this manually. You have saved 30 minutes at least of your time, right? Like on one click, which is like a massive improvement for any sort of DeFi. So like this kind of thing is what really make a product like Wormhole Settlement extremely interesting, because you can see how not having it would actually make the entire user experience much worse actually. So yeah, these are the kind of chain abstraction is another one, because if you actually use something like settlement, the user just barely see what's happening. Like they have no idea that there is a swap being made under the hood. Like so, it really enforced the whole theory, like the whole strategy of having basically any sort of interaction with the user not knowing from one chain to another. And I think DeFi just needs to have that as a default today, because we can't keep going on like 20 steps for bridging and so on. So question swap, this is a normal, like that's just like one of the screenshots that you can have today, but I'm sure if you use any sorts of DeFi, DeFi app. You must have seen it. This is basically on digital store, so this is more like Solana stuff, but like it's what that's what look like a swap plus action. Basically, you deposit like you want to take this one, I can use it. Okay.
I just wanted to say that it's a good example for a settlement, the swap plus action, how it will work actually. This is live, or this could be live, with any asset. So let's say you are on Arbitrum. Gilo Sol is on Arbitrum through NTT, and you have Sol on Solana. And so instead of needing to swap first, bridge next, and take an action to deposit it into a pool, you can all do it on one step. From Solana, the swap to Girosol, then the bridge from Solana to Arbitrum, and the staking, let's say, or depositing into a vault could all happen just in a couple of seconds with the help of the settlement product, which it's way better user experience than doing all the steps after each other and doing a signing for each of them. So.
Yeah, and it's not just better because you don't have to do the steps. Like you have to think that some people don't even know they have to do those steps. So it would actually, they would never go to the end of an action. Like they would never reach the full potential of a DeFi app. Just because knowing that you need to bridge, then you need to stake, then you need to go into that different vault. Like they would not even get there. So I think settlement is one of the products that really unlocked a massive adoption actually. So this is Connect. We already spoke about it. It's we can just like maybe just go quickly over it. But Connect is something very easy. If you need it, if you don't have a front end, for instance, if you want to try for the hackathon and like you did entity and then you just want to connect it, like it's your go-to product. It's very easy to integrate. Yeah. So regarding the bounties. What we're interested in is, entity, any sorts of messaging like the TSSDK is your go-to product, I guess. One more settlement is also something we really keen on seeing, but again, it's really up to you. Like we don't have one specific project that we want to see. Like we don't have a we as long as you think it's good and it's useful for it, it's a product that you see a use for it and you think people will use it, then we are happy to see it. But just so we are like on a few things that we want to align, so it's a total amount of 3K. We kind of like always give ourselves the right to decide if there is like one team that maybe has done an amazing thing, so we give it only to one team, or sometimes maybe there's 3 teams that have done really well. So like that is really based on each hackathon. Like we don't say it's going to be 3 winners. We just say, it's really based on whatever submission we have. But just a few things. So any normal product that is integrated is good to go. However, we don't consider just for Connect alone because, as you can understand, it's 3 lines of code in the React components. But yeah, it's not the hardest integration you can do. So it has to be a working implementation. And to make our work a bit easier, often we ask for a transaction hash that is fully working, so we can just see that it has happened. Because yeah, we go through a lot of reverse, so that makes our life a bit easier. And one thing we really love, and it's actually the highest ROI, and I think it's one of the reasons why we keep doing hackathon, it's really product feedback, especially on the documentation and on any product from Momo that you're using. Like we find this is the best way for us to improve anything we do. Is the DevX, the UX, the doc. Is if people build with us and they just, what do you think about it? Like, could it have been easier? Could it have been like better? Do you think it was great, or you think another internal protocol is much easier? Like we are so interested in this because we just use our product all the time, so we don't see the flaws the same way. And I think we want to make it as easy for the dev as possible. And there's no better people than developer using our product. So really, we are super grateful if people can give feedback once they used it always happy to jump on the call after the hackathon. So yes, that is one of the things we are quite grateful for.
Where we find the documentation?
The doc?
Yeah.
I will send it to you.
wormhole.com/docs. DOCS.
We will make a and the doc has like a lot of AI integration for like developers, so you can you can really go around like any suggestion, anything we take it.